Hello everyone, this is Srikanth and welcome to UI Electrics. Today we are going to deal with power systems, part A, transmission. In fact, power systems is nothing but generation, transmission and distribution and application. Study of generation, transmission and distribution and applications is nothing but power systems. So far we had covered generation. Now we have entered into transmission. Transmission is nothing but transmitting the power from the load center. It may be from the generating station or it may be from the load center to consumer terminals. So it has to be considered as transmission. So the basic Indian configuration is as shown. Please do make a view of this. So the generating station may be of 11 kV or 33 kV. So from there immediately we can find a transformer. Usually these are step-up transformers. These will convert 11 kV to 132 kV. From there you can see 132 kV to 33 kV. kV by 11 kV. To 400 watts. Yeah, if you do consider this one, this is nothing but primary transmission. This is secondary transmission. This is primary distribution and this is secondary distribution. Please do consider examination point. In examination point of view, questions may be of step. In primary transmission, what may be the voltage? We have to go for 132 kV as per Indian standard and as per as Indian standards, not less than 132 kV. So please do make a screenshot of this. So this is the general flow of power system. So far, if you had observed, only the transformer used at generating station will have step up voltage. Remaining all will have step down voltage, 132 to 33, 33 to 11, 11 to 400. These all comes under step down. So whereas only this at the generating station will have step up. So this is known as power transformer, and all this comes under distribution transformers, right? Distribution transformers, right? I will whenever the power transformer, distribution transformer, whenever the concept of transformers whenever the concept of transformers has come, I will discuss about power transformers and distribution transformers. So that is completely a separate topic. Please do remember. That's it. Right. Now we are going to discuss about transmission, right? Okay. In transmission we have two types of transmission. One is AC transmission and DC transmission. So as far as we people know that we can utilize both of these transmission systems, but there are few factors which affect what to employ, AC or DC. We must be aware of HVDC, but not very much HVAC. We use it, but not much for transmission purposes. So please I will add some point. Please note it down. Skin effect. Skin effect exists in AC transmission, but no skin effect in DC transmission. Whereas charging current is nothing but whenever a conductor has some potential with respect to ground, it acts as a dielectric. Dielectric is nothing but a capacitor, right? Nothing but a capacitor. So a capacitor generally draws some charging current IC. Charging current IC. This charging current is known as IC, and it causes some major losses in transmission. So it will exist only in AC. We can't find charging current in DC. So next comes regulation. I want to say about voltage regulation. Regulation voltage is very poor here, very poor, and it has good regulation voltage. See, regulation voltage in terms of good means good should have regulation. If a system has to be set as good regulation voltage, it should have low value of regulation. I hope you got my point. If it is not in case, let us make an example. A system having good regulation means it should not have voltage drop less than 2%, 1%. But for a bad regulation, it will be of 5%, 10%. 10% means for 400 volts, 1% is 4. Then for 5%, it is 20 volts. Yeah. So next comes insulation requirement. AC systems require more insulation, whereas DC requires less insulation. So the only advantage of AC system is step up and step down. We can step up or step down. Access will be easy. Access is easy, but it is very difficult for DC transmission. Difficult. Not the only one. It also has one more beneficiary using a AC is switchgear equipment is less cost compared to DC. So whatever may be, minimizing the cost is the main objective for any individual or any organization. So these are the factors, using AC transmission and DC transmission so far in examination point of view. So please note it down: skin effect, charging current, regulation voltage, insulation, step up or step down access, switchgear equipment, right? So we are shifting to next topic. I have to add a point for this: volume of copper. Volume of copper is always proportional to 1 by V square cos square phi, where V is the applied voltage, cos phi is the power factor of the load. So for if cos phi goes on increasing, power factor goes on increasing, volume of copper required will be decreased. So it is inversely proportional, similar to that of voltage. So please note one more table here. Depending on this, I am going to add DC 2Y, DC 3Y, single phase AC, 3 phase 4Y, right? So if the volume of copper required for DC 2Y is taken as reference, so V1 is reference, So for this it requires V2 is equal to 0.25 V1 times, right? So this takes 2 by cos square phi V1, whereas this one takes 1 by 2 cos square phi V1. I hope you got this point. This is a very important and repeatedly asked questions. Questions will be in a way such that if DC two-wire system our voltage something, say V1 is equal to X and V2 of voltage X, then what might be the volume of copper required? So we actually goes for the formula, this one. So volume of copper V1 by V2 is equal to X1 X2, let us take X1 by X2. Then we have to calculate it. See, please note these formulas and do practice with some available dumps you can find out in online. So please note this. Okay, this is up to the part of today. Please do share to your friends. Thank you. This is Shrikant, and thank you so much.